Hey, this is Pete with AquaFX with another edition of AquaFX.net. I would like to go ahead and display our Octopus RODI unit. Now this is going to be our top end unit as far as efficiency is concerned, lower wastewater ratios. First thing we're going to do, we're going to inspect it for any damages. As I give it a visual inspection, I don't see any damages. Next, I'm going to go ahead and hook up my 1/4-inch water supply. I've gone ahead and done this ahead of time. I'm going to now take my 110 volt power source and I'm going to plug this into my receptacle. I'm going to notice my power light turns on and I'm also experiencing a timer countdown. Once I get to 0, my unit should begin production mode if there's positive pressure applied. My source light is blinking, indicating to me that I have a low pressure situation, which is very important so that we do not burn our booster pump up from running dry with no water. And this is our low pressure switch, which is indicating that there's no pressure. Thus, the pressure is not being seen by the switch. I'm now going to go ahead and turn on my water supply. What I will expect is that the source light will go solid, the working light will turn on, as well as the flush light, letting me know that we are going to begin to do a RO membrane flush. I heard my solenoids trigger, letting me know that everything is going as well. It starts from 30 seconds and counts down to 0. This is actually doing a membrane flush, indicated by the illuminated flush light. As we get down to 0 seconds, it's going to go ahead and go into just working mode, making RO water. We'll notice during this time that our pressure gauge is close to zeroed out. Even though my booster pump is running, I can feel a light vibration right now. There, our timer has finished its flush cycle, is now in production mode. We're seeing zeros, and this is a timer. This is just going to let you know how long your unit's been making water. I see here that I'm still at 20 psi. What I do is I go to my waistline, and I slowly start to restrict this waistline until I either achieve 80 psi or a 1-to-1 wastewater ratio, whichever happens first. You can see my wastewater is actually a little cloudy. This is to be expected. This is air escaping from the system. There will come a day when this line runs a clear stream of water. I can compare my two flow rates, and I can see that my wastewater's providing a little bit more flow than my product water, so I can then restrict the valve a little bit until I get those flow rates about equal. If your pressure gauge gets upwards of 75-80 psi before this takes place, you must stop when you reach 80 psi so that you don't run your unit at unsafe pressures. If I open up my waistline more, what I will expect is that I get a little bit more wastewater, but you can see that I haven't really sacrificed my product water flow that much. What this is doing is this is allowing me to get greatest membrane life possible. Membranes are pretty expensive, and we like to see them last as long as they possibly can. I now have my gauge getting upwards of 70 psi, which is fine. As you more pressure, the better. You're going to experience lower TDS after the RO membrane, and you're also going to get your full gallons per day, whatever the unit's rated for, 50, 100, or 200 gallons per day. We've even snuck a couple of 300 gallon per day octopi out the shop. So our unit is now making water. Our DI canister is starting to fill up, and it will fill up a little slowly. As discussed in other videos, every now and then you're going to see an air gap take place in this DI filter. What I can do is I can lightly unthread the canister, and as I unthread the canister, notice the water level is now rising more predominantly within the DI. And this will happen all the way to the top. If I forget to tighten the canister again, it will leak out of the seam. So I wait for it to be about 90% full, almost completely to the top. And then I'm going to go ahead and close the canister completely. I can do it firmly with my hand. If you have your filter wrench, go ahead and use that. And this has eliminated that air gap, keeping the canister full of water. Again, as we said before, the air gap does not affect any of the quality of water or the production of the unit, but some folks just don't like the way that it looks, so we go ahead and eliminate it. I've now got good product water exiting my unit. The unit's been making water for about 2 minutes now, and that's what's indicated by the 02 on the countdown. My pressure gauge is hovering a little bit above, right around 70 psi. And now what I'm going to do is I'm going to go ahead and shut my product valve off, which you could be using a float valve or any other sort of stop device to go ahead and block that water. At this point, my unit will build pressure for maybe 30 seconds, and we're going to go ahead and wait for the full light to illuminate, letting us know that we are full, at which point a final membrane flush will take place. This can take anywhere between 30 seconds to 2 minutes, depending on pressures. Now my flow light has illuminated, and we will go into a flush mode here in about 30 seconds. And here we go. Now we're going to count down from 15 to 0. And again, the flush light is illuminated, letting us know that we are performing an RO membrane flush. After the flush is finished and we get back down to 0, we're actually going to see our TDS displayed. Now that my unit is full, we're seeing a 9 parts per million on the TDS meter. This is just our RO water. This is not RODI water. So with my 150 parts per million incoming source water, this is ideal. Anything below 15 parts per million is going to let me know my membrane is working properly. You're going to get your most accurate reading immediately after the unit shuts off. You don't want to walk away for an extended period of time. Come back and look at the unit. This number climbs steadily. So 9 parts per million out of my RO means my DI should get about 500 gallons of capacity, assuming no chloramines and no dissolved oxygen in the water. It is important to note with your Octopus unit that you never shut off the wasteline completely. It is important that you always have at least a 1-to-1 wastewater ratio between the waste and the product water. In addition to that, when your membrane flushes itself, you're actually eliminating TDS creep from running into the DI portion of the unit, so you're not unnecessarily burning up your DI. That cyclic membrane flush, in addition to the low wastewater ratio, make this one of our more efficient units that we offer. I look forward to you setting up your own Octopus and contacting me with any questions. Thank you.